a subprogram in which we write certain set of code, and it is going to do a small task of a bigger task. Okay? You have already written functions for creating linked list, or say sorting of numbers, or say swapping of two numbers. So we have written functions. Okay. Now let us see what do you mean by recursive functions, or what is this recursion? So recursion is nothing but it is a way of applying a concept which the text of the definition refers to the that is being defined. Meaning we define the problem in terms of itself. Okay. So recursive function is what? A recursive function is a function which is going to call itself. A function which is going to call itself is called as a recursive function. For example, if we have main function. So if this main function, okay, we have a main function something like this. In the main function, this is the body of main. In the main function, if I call main again, then this main function becomes a recursive function. So this is the definition of a recursive function. A recursive function is a function that calls itself. Okay. But if the definition is not only this much, because if a function is calling itself, now this process will repeat and repeat. So there should be a termination condition, right? Otherwise it will go in an infinite loop. Okay. So recursive function is a function which calls itself repeatedly till a condition is satisfied. So there should be always a termination condition in this recursive functions. Okay. So the recursive function call must use a different argument than the original one. Meaning this is the recursive call. You have a main function. This is a recursive call to that main function. So this argument should be different than this. Okay. Every time you cannot have the same argument. So that also means that recursive functions should have an argument. Okay, recursive functions should have some argument which is going to change every time. So that is what this note says. Recursive function call must use a different argument that the original one. Okay. Otherwise, the procedure would get into infinite loop. Meaning the function procedure is nothing but the function. Function will go in infinite loop. Argument is not changing. Okay. We have one function here which is factorial. I'm trying to find factorial using a recursion. Okay, I don't know if this last slide is visible, so better I will this function is there on the next slide. We'll just revisit. Before that, we'll clarify this slide. So we have seen a recursive function. So what is a recursive function? Recursive function is a function which calls itself repeatedly till a condition is satisfied. Okay, I repeat, recursive function is a function which calls itself repeatedly till a condition is met or till a condition is satisfied. Okay, that is called as recursive function. So the contents of recursive function will be these two things, that is the base condition and the recursive base condition, or you can say termination condition, base cases or termination condition. So what are these base cases? Values of input variable for which we perform recursive call. Okay. So in short, there should be a termination condition and there should be a recursive call, where in every recursive function. Okay. So in the recursive function, there are these two things which are important. There should be a termination condition and there should be a recursive call. As we said, the recursive call should always take a different parameter. Once we see an example, all things will be clear. So we know what is factorial. Also, we know that how do we find a factorial by using loops. Okay. So here we'll find a factorial, but we'll not use loop to find it. We'll use function. Okay. We'll use recursive function. So this is the main program. Before that, I tell the compiler that fact is the name of the function which is going to take one argument of type integer and it is going to return an integer type. Okay. Then I start with main. I declare a variable n. I ask the user to enter a positive integer. Whatever user enters, that will be saved into n. And then I say factorial of whatever is the number entered by the user, that is n, is this particular thing. And what is that? It is a function call. So you know that whenever a function call appears, the control will be transferred to that place where the function is defined, and there the parameter is also passed. So if the user has typed in the value of n as say 5, the 5 will be passed here, and this n is going to become 5. Okay. Then I check if so. This is the termination condition. As I said, right, there are two things which we find in factorial or in a recursive function. So one is this base condition or termination condition, and second is the recursive call. So this is the recursive call. What was the definition of recursive call? A function, a function calling itself. So this fact is calling itself. So this is called as a recursive function. Okay. So we also know that whenever the control is transferred to the function, the local variables are created on the stack. So there is a stack maintained, and in that the value of n or whatever other local variables here will be saved. So there will be n, there will be some value to this n. What is that? It is 5, which is entered by the user. So 5 will be saved there. I check if 5 is less greater than or equal to 1. So the condition is true. Once the condition is true, control comes here. I have a condition, and there is an expression here, n into fact of n minus 1. Okay. So what is n? N is 5. N minus 1 becomes 4. Okay. So I recall the same function fact, but this time with the parameter 4. So that is what I was telling you. Every time the parameter will change. So earlier it was 5, now it has become 4. So every time it will go on decreasing. It becomes 3, 2, 1, and finally once it becomes 0, this condition will be false, and control comes here, and I will start returning. Okay. Now there is something called as backtracking, which will go on solving this particular equation. So this is we'll revisit this function. Okay, we'll see this function in detail, but before that, you can see calls will be something like this. Okay, main function called here. I had assumed 5, but assume 4 as the parameter which is passed from the main function. So this recursive factorial 4 will call the same function again, this time with value as 3. That will call again, it will pass the value as 2. The same function will call itself again, the value will be 1. Same function will call itself again, the value will be 0. Once the value is 0, there is no call. Here, once the value of this n becomes 0, I don't call. This condition becomes false, control comes here. So there is no more calling now, it is returning. So 1. So fact of 0 has returned 1. Okay. I put that back into this equation, n into fact of n minus 1. So fact of n minus 1 is executed, and I multiply n. Okay. So I get 1 into 1 is 1. I return this. So this is backtracking. 2 into 1 is 2. I return that 2. Then 3 into 2, I return 6. Then I return 6 over here. 4 into 6, 24. The final answer is 20 is returned to the main program. Okay. And all these intermediary recursive calls are all stored on the stack. Okay. We'll revisit this. I will show the contents of the stack once again, but hope you all have understood what is recursive functions. Okay. A function which is calling itself. So to understand recursion, we have taken an example of factorial. So this function I have rewritten again on the next slide. Okay, this function I have again rewritten on the next slide. We'll try to trace this once again. So as I said, there is a statement for keeping track of local variables. I have n here. Okay, I will just write n over here. So this is my n. I will assume that 4 is passed by the main program. The value of n initially is 4. So I write that 4 over here. Then the control comes inside. We'll try to trace this, okay, with respect to the stack. So initially the value of n is what? 4. So is 4 greater than 1? Yes, the condition is true. People you have not understood, just concentrate on this slide, you will understand. And this slide is very important. Only if you understand this particular thing, you will understand the next or other programs on recursion. Okay. The value of n is now 4. So 4 is greater than or equal to 1. Yes, the condition is true. Once the condition is true, control comes here. What I have here, I have return. But this is an expression. So you know what is an expression. Expression is something which is going to result into a single value. Okay. So this single value? No, this is some expression now, in which I know what is n. So n is 4 into, okay, I will write the expression over here, into what I have is, I have fact, instead of writing full fact, I will just write f. So I have fact of n minus 1. N is 4, 4 minus 1 is, okay. So this becomes something like this. Now this is going to call the same function again. Okay. I am calling the same function again. Okay. What happens is another entry is pushed onto the stack. What is the value of n now? It is 3. Okay, because I am calling this f of 3. The value of n will be 3. Is 3 greater than 1? Yes, the condition is true. Control comes here. I have again an expression here, which is 3 into fact of 3 minus 1, which is 2. Okay. Next, this is a call to the same function again. So I call the same function with the value of n as 2. Okay, with the value of n as 2. Is 2 greater than 1? Yes, the condition is true. Control comes inside. I have a call here, which is what? F of n minus 1. N is 2. 2 minus 1 is 1. I have this particular call. So this is again a call to the same function. This time the value of n is 1. And I call fact of what? 0. Or before that, I just check the condition. Is 1 greater than or equal to 1? So yes, it is equal. So control comes here. The expression will be 1 into fact of 1 minus 1 is 0. Okay. Now this is called again. Okay. I just call the same function again. This time the value of n is what? 0. And I have this f of 0. Okay. So control comes here. Is 0 greater than or equal to 1? No, the condition is false. Once the condition is false, else part is executed. Okay, else part is executed. And what is the else part? I am returning 1. So this fact of 0 is executed now. Okay, this fact of 0 is executed. It returns what? It returns 1. Okay. So what is 1 into 1? It is 1. So this is your factorial calls, or this is your recursive calls. Okay, whatever is there on the stack now are the recursive calls. Now finally I have reached the else part. F of 0 is executed. It returns 1. Okay, so 1 into 1, I will just go on solving it now. 1 into 1 is 1, so I will return it. Where do I return? From wherever the call was made. Okay, so the call was made from here. Fact of 1 is executed now. It has brought back the value 1. So 1 into 2 is what? 2 into 2 is returned. Okay. 2 is returned. So fact of 2 is executed, and it has brought back the value, which is 2. Now this is an expression. 2 into 3 is 6. So fact of 3 is executed. It has brought back the value, which is 6. This is called as backtrack. Whatever now and going back to the previous call is called as backtracking. So f of 3 is executed. It has brought back the value, which is 6. Okay. Now till here it is clear. Now the last call or the was from main function. So from main function, what it was something like this: f of 4. Okay. From the main function, it was something like this: f of 4. So f of 3 is executed, it has brought back the value which is 6. 6 into 4 is what? 24. So this is executed, it has brought back the value which is 24. So if I go to the previous slide, if you see, this was that f of 4, this has brought back the value. So I print 24. This particular statement is going to print 24. So fact of 4 is 24, it will print, return 0 will terminate the program. Okay. So this is how those recursive calls are. I will just discard this. Come back to your screen. Is that clear? Yeah, anyways, I'm not able to hear you. So hope that is clear. Somebody can put in chat. Okay, okay.
Yes, sir.
Okay, enough.